In the first few weeks of July, a number of scientists have been watching with genuine dread since 1997 finally broke. The Niño 3.4 index, the single most important number in global climate forecasting, shot above 2 degrees Celsius, officially crossing the threshold that defines a super El Niño. But here's the part that's actually alarming forecasters. This isn't just matching 1997, the strongest El Niño ever recorded. Every single climate model currently tracking this event says 2026 is on pace to beat it, and some are projecting a peak so extreme it would shatter the old record by a wide margin. To understand why this specific threshold matters so much, you first need to understand how scientists actually measure and classify an El Niño event. The Niño 3.4 region is a specific strip of ocean along the equatorial Pacific that climate scientists use as the primary benchmark for gauging El Niño's strength, tracking how far sea surface temperatures there deviate from their long-term historical average. A standard El Niño is declared once that anomaly crosses half a degree Celsius above normal. A strong event typically exceeds 1.5 degrees, but a super El Niño, the rarest and most consequential classification of all, requires sea surface temperature anomalies to exceed and sustain a threshold of 2.0 degrees Celsius above average for a period of at least 3 consecutive months. Since 1950, only 3 events have ever officially crossed that line. In 1982 to 1983, in 1997 to 1998, and in 2015 to 2016. The 2026 event has now become the 4th. What's making climate scientists sit up and take notice isn't just that the threshold got crossed, it's how fast it happened. After 2 consecutive years dominated by La Niña, conditions, the tropical Pacific flipped decisively in April, with the Niño 3.4 index crossing the initial El Niño threshold of half a degree. From there, the pace of warming became genuinely unprecedented. The index reached a full degree by May, climbed to 1.6 degrees by June, and then shot above 2 degrees in the first few weeks of July. And acceleration that significantly outpaced the speed at which any prior El Niño event on record has developed. Independent climate researcher Zeke Hausfeather, who has been tracking this event closely, noted that no prior year in the entire 45-year satellite record has been anywhere close to this warm this early in the season. Not 1997, which was sitting at 1.6 degrees at the same point in the calendar, and not 2015, which was sitting at just 1.3 degrees at the equivalent date. What makes 2026's trajectory even more remarkable is the starting point it launched from. The 2015 to 2016 Super El Niño benefited from what scientists call a precursor effect, meaning the Pacific was already running unusually warm heading into that year before the main event even began building. This year's El Niño launched from the exact opposite conditions, genuinely La Niña-ish, cooler than average ocean temperatures in January, before undergoing what can only be described as an explosive reversal over the following 6 months. That distinction matters enormously to climate scientists, because it suggests the underlying mechanisms driving this event are producing genuinely record-setting intensity from a cold start, rather than simply building on residual warmth left over from a previous climate pattern. The modeling consensus behind this event is about as unanimous as climate science ever gets. An analysis combining results from 667 separate models runs across 14 different international modeling groups found that sea surface temperatures in the Niño 3.4 region could peak somewhere around 3.59 degrees Celsius sometime between July and December of this year. More than 91% of those individual model runs predicted this would become the strongest El Niño event in the modern observational record, surpassing the previous record set during the 2015 to 2016 event when temperatures peaked around 2.75 degrees. Every single one of the 14 modeling groups involved in that analysis placed their median forecasted peak at super El Niño intensity, and all but one placed their median forecast above the previous 2015 to 2016 record entirely. Multiple independent meteorological agencies have echoed these same findings using their own separate forecasting systems. The Southern Oscillation Index, another key metric scientists use to track this climate pattern, dipped to negative 2.68 during July, passing its own version of the super El Niño threshold. The multivariate ENSO index, which combines several different atmospheric and oceanic measurements into a single composite score, dropped from negative 0.3 in April and May all the way to negative 2.5 in June and July, a shift in intensity that ties the strongest such change ever recorded at that point in the calendar year. A record previously set in 1997, right before that year went on to become, at the time, the strongest El Niño ever documented. Forecast models from the United States, Europe, and Australia, 3 entirely separate modeling authorities using different data and methodologies, all currently agree that this event's projected 2026 intensification is outpacing the evolution of both the 1997 and 2015 Super El Niño events, a level of cross-agency agreement that meteorologists describe as a genuine code red scenario for the global atmosphere. So why does any of this actually matter beyond being an impressive-sounding statistic? Because El Niño's strength directly correlates with the severity of its downstream effects on weather patterns across the entire planet, and those effects tend to peak roughly 3 months after the ocean anomaly itself reaches its maximum. Current forecasts show this event peaking sometime between October 2026 and January 2027, meaning its most disruptive global impacts, changes to rainfall patterns, hurricane activity, and regional temperature extremes across multiple continents, are expected to concentrate specifically in the fall and winter months. The Climate Prediction Center's 3-month outlook already shows above average precipitation likely across the southeastern United States, along with portions of the Four Corners region and the broader Southwest. From September through November, a preview of the kind of widespread precipitation pattern shifts a Super El Niño of this magnitude tends to produce. Looking back at what the previous Super El Niño events actually produced on the ground helps put this year's trajectory into sharper, more tangible focus. The 1997 to 1998 event, still widely regarded as the most disruptive El Niño in modern memory before this year's development began, triggered catastrophic flooding across Peru and Ecuador, drove severe drought conditions across Indonesia and parts of Southeast Asia that contributed to widespread wildfires and dangerous air quality across the region, and produced one of the most active and destructive Pacific hurricane seasons on record, while simultaneously suppressing global temperatures during 1998, ended up setting a record that stood for years afterward, a direct consequence of that event's ocean heat, eventually radiating out into the broader atmosphere. The 2015 to 2016 event produced a strikingly similar pattern of global disruption, contributing to a severe drought across southern Africa that pushed tens of millions of people into food insecurity, while simultaneously fueling one of the most extreme wildfire seasons Indonesia had experienced in decades, and helping push 2016 into the record books as the warmest year ever measured at that time. Given how closely this year's event is already tracking ahead of both of those historical benchmarks, climate scientists are understandably cautious about drawing firm conclusions regarding exactly which regions will see the most severe impacts this time around, since the specific geographic distribution of El Niño's effects can shift, somewhat from event to event, depending on exactly how the broader atmospheric circulation responds. What scientists are confident about, however, is the general category of impacts a Super El Niño of this magnitude tends to produce: altered monsoon patterns across South and Southeast Asia, an elevated risk of drought across parts of Australia, Indonesia, and Southern Africa, increased flooding risk along the west coast of South America, and a substantially reshaped Pacific and Atlantic hurricane season, with tropical activity typically suppressed in the Atlantic basin while becoming considerably more active across the eastern and central Pacific, closer to Hawaii and Mexico's Pacific coastline. One additional complicating factor scientists are grappling with in analyzing this specific event involves the broader context of long-term ocean warming itself. Because the entire global ocean has been steadily warming over recent decades due to accumulated greenhouse gas emissions, researchers increasingly find it necessary to cross-check headline Niño 3.4. Anomaly figures against something called the Relative Oceanic Niño Index, a metric that measures the tropical Pacific's temperature specifically relative to how much the rest of the world's oceans have warmed over that same multi-decade period. This distinction matters because a raw temperature anomaly figure calculated against a fixed historical baseline can potentially overstate an event's true relative intensity in a world where the overall ocean baseline itself has been steadily climbing year after year. Scientists tracking this nuance say it doesn't meaningfully change the conclusion that 2026's event is exceptionally strong, but it does add an important layer of scientific rigor to exactly how headline comparisons against events like 1997 and 2015 ultimately get interpreted and reported. The economic and humanitarian stakes tied to how this event ultimately unfolds are considerable, given the scale of disruption previous Super El Niño events have historically produced. International aid organizations and agricultural forecasting agencies have already begun incorporating this year's rapidly strengthening event into their own seasonal planning models, particularly for regions in East Africa, Southeast Asia, and parts of Central and South America that have historically proven most vulnerable to El Niño-driven disruptions in rainfall and crop yields. Given that this event is currently tracking ahead of both the 1997 and 2015 benchmarks in terms of speed and projected peak intensity, several of these organizations have specifically flagged the coming fall and winter months as a period requiring heightened monitoring and early resource positioning rather than waiting for the kind of after-the-fact humanitarian response that characterized parts of the international community's reaction to previous major El Niño events. If you want to stay ahead of how this record-setting El Niño continues developing, go ahead and like this video and subscribe, because we'll be tracking every model update as this event pushes toward its expected peak later this year. The global temperature implications of an event this strong extend well beyond just this year alone. Historically, global temperatures lag the tropical Pacific's El Niño signal by roughly 3 months, which means an event peaking in November and December of 2026 will actually exert its largest warming influence on the following year, 2027, rather than on 2026 itself. This exact pattern played out during each of the previous major El Niño events in 1997 and 1998, in 2015 and 2016, and again during the more moderate 2023 to 2024 event, where the year the El Niño actually developed in was warm, but the following year ended up shattering global temperature records entirely. Based on that same historical relationship, current projections suggest 2027 could land around 1.71 degrees Celsius above pre-industrial levels, a genuinely alarming figure that would represent one of the most significant single-year jumps in recorded climate history. There's an important caveat scientists are careful to include in every version of this forecast, however. Being on this explosive pace in June and July doesn't guarantee the event ultimately peaks at super El Niño intensity, since roughly a third of past events that looked similarly aggressive at this stage of development ultimately topped out below the very strong tier once autumn conditions fully set in. But researchers are also quick to note that every single one of the 3 previous confirmed super El Niño events looked essentially identical to this one at the same point in their development, which is precisely why the overwhelming majority of current models are treating a genuine, confirmed super El Niño peak as the most probable outcome rather than a worst-case scenario. Scientists studying the aftermath of previous super El Niño events have also identified a consistent pattern worth watching. For once, this one eventually peaks, since all 5 super El Niño events recorded since 1970 have been followed by a notably rapid decline into either La Niña or neutral ocean conditions, suggesting that whatever extreme weather this event ultimately produces globally, it likely won't linger indefinitely once its peak intensity finally begins to fade sometime in mid to late 2027, even if the record it sets along the way ends up standing for years to come.